High tunnels can vary greatly in size, complexity, and use, but in general are typically described as non-permanent structures at least 6 feet in height, covered with a single layer of transparent polyethylene film that provides season extension capabilities, crop quality improvements, and soil conservation options for agricultural producers. However, the basic design can be modified in numerous ways by adding things like mechanical ventilation, a double layer of polyethylene, or raised beds. There are many things to consider before deciding what products will be grown in a completed structure, identifying a potential location, or even making the decision to utilize high tunnel technology. Each property and situation has unique characteristics that need to be examined in detail, then weighed against available natural and financial resources, as well as the goals of the producer. This video will provide you with tools to examine your own property for potential high tunnel sites, including tunnel types and important points such as light, wind, drainage, and current land usage. Let's begin by taking a look at the types of tunnels available in today's marketplace. There are Quonset or hoop house styles, Gothic arch, and multi-bay tunnels. In general, all high tunnels are comprised of a series of plastic or metal vertical frames that are connected by horizontal roof beams called purlins. The frames are secured to the ground by posts reaching 2 to 3 feet beneath the soil, and once secured are typically covered with 6 mil greenhouse-grade UV-resistant polyethylene film. Quonset or hoop house tunnels feature a rounded roofline with sides that curve to the ground, or a rounded roofline adjoining 4 to 6 foot high straight sidewalls. The straight sidewalls add additional height to the structure, allowing for taller crops and improved equipment access. This type of structure is best suited for 3-season production, as the rounded roofline may not support the weight of snow or ice. In fact, the increased weight could cause damage to not only the film, but the frames themselves. As such, it is recommended to move the covering during winter months. Gothic arch-style high tunnels have a peaked high roof with straight sides. Because of its peaked roof, the Gothic style may be better suited to accommodate snow load when compared to a Quonset flatter roofline. As a result, these structures lend themselves well to 4-season production, especially greens or other cold weather crops before or after warm season produce. Multi-bay tunnels are typically comprised of several Quonset-style structures connected horizontally at the gutters. This type of tunnel often increases the amount of acreage under cover and is usually tall enough to allow for tractor access. Multi-bay tunnels are commonly used in fruit production, particularly for cherries. These systems require the side bundling or complete removal of the frame cover in order to minimize winter damage. Some tunnels in both Quonset and Gothic arch style are engineered to be built upon skids or on a V-track system to provide for infield tunnel mobility. Movable tunnels utilize a series of specialized anchors to secure the tunnel either directly to the ground or to the track itself, as with the V-track system. Movable systems are more expensive than fixed tunnels due to the need for additional structural support when moving the structure, but advantages include options for advanced crop rotation and soil improvement. These descriptions primarily provide information about the tunnel profile, but there are also differences in the tunnel end walls. End walls should accommodate the needs of the producer and vary from temporary ends like curtains or those that roll up, to more permanent framed ends with entryways designed to accommodate both walk-in and tractor access. Each high tunnel manufacturer will be able to provide more detail about available types, customized systems, warranty information, pricing, and installation instructions. Keep in mind, if constructing the tunnel with financial assistance from the USDA Natural Resources Conservation Services, NRCS, the structure must be new, as well as designed and installed according to the manufacturer's instructions. While assessing what type of structure to install, each producer must also examine the property for potential high tunnel sites based on the benefits of each type of tunnel and with particular attention to a variety of issues that may impact the success of a tunnel, such as soil fertility, weed and pest pressures, irrigation, drainage, airflow, quantity of sunlight, and site accessibility. Do not underestimate the importance of accessibility because high tunnel managers will need to visit the tunnel regularly to raise and lower the sides for temperature control, to irrigate, and to make regular plant and soil health assessments. For each potential site, identify water access points such as bibs using existing lines and hoses, and then determine if the location will need a frost-free hydrant to maximize the tunnel's season extension capabilities. Because tunnels must be situated to receive the maximum amount of sunlight each day, study possible locations for potential shade issues that may arise during both traditional and winter growing seasons. Avoid areas with shade cast by nearby trees and buildings, as full light access is the most desirable for owners whose primary interest is in growing season extension. Pay close attention to objects that may not be an issue during the traditional growing season when the sun is high in the sky, but that can inhibit light access during winter months, such as small sheds and shrubs on the south side of a tunnel. If a shade-producing object cannot be avoided, consider sites that are impacted only in the late day. Ideal placement to maximize sunlight varies based on geographic location. Tunnels south of the 40th parallel are often positioned so that the tunnel's purlins are situated in a north-south configuration, but owners north of the 40th parallel may see better results with tunnels oriented to the east and west. Next, look closely at any area under consideration and identify existing pest or weed issues because they will flourish as well as planned crops in the high tunnel environment. Consider the least impacted area, principally areas without perennial weed issues, and develop a plan to eliminate pressures before tunnel site preparation and construction. In addition to weed and pest pressures, assess the productivity of potential sites and complete a soil test to identify current nutrient, heavy metal, and salinity content so needed amendments can be made prior to or during site preparation. If soil contamination is a problem due to heavy metal or high salinity levels, as may be found in some urban or reclaimed sites, constructing raised beds that are lined and framed or that utilize similar containerization can minimize risk from contaminated soil. It is important to note that for growers receiving financial assistance for high tunnel structures from USDA-NRCS, raised beds are acceptable, but the roots of the plants must have access to the natural soil profile. Soil quality is also dependent on the drainage and water retention capacity of the soil. A high tunnel site needs well-drained soil sloping gently away from the interior of the tunnel. For slope sites, investigate placement options to minimize the impact of upslope rainwater runoff and potential gullying. If the site does not allow optimum placement of the tunnel, additional structures such as diversions can be constructed to redirect surface water away from the tunnel, minimizing drainage and erosion problems. If other considerations point to a site that has less than desirable drainage, consider investing the time to design and regrade the site prior to site preparation or tunnel construction. This may improve uniform distribution of irrigation water and redirect rainwater runoff from the frame and sidewalls to prevent erosion at the tunnel foundation. If foundation erosion is a particular concern, consider installing a gravel-filled trench or tiled drainage system. High tunnel production is completely dependent upon irrigation, primarily drip tape, soaker hose, or overhead irrigation systems. Some growers choose to utilize rainwater catchment systems to supplement water needs and even reduce erosion caused by rainwater runoff. Yet caution must be exercised in this consideration because the tunnel may not be engineered to withstand the increased weight of rainwater catchment system, captured water, or snow load. While most high tunnel growers produce crops directly in the soil profile, irrigation and drainage concerns may be relieved by implementing a raised bed system. As mentioned earlier, for growers receiving financial assistance for high tunnel structures from USDA-NRCS, raised beds are acceptable, but they must be in contact with the natural soil profile. Utilizing containerization, including bag or tube type systems, may increase irrigation efficiency and drainage, but may not be permitted when receiving NRCS financial assistance through programs like AMA, Agricultural Management Assistance, or EQIP, Environmental Quality Incentive Program. Check with your local USDA-NRCS representatives prior to installing alternative growing medium or raised beds, altering your tunnel site, or making structural changes. As with drainage, proper ventilation is extremely important because temperature and airflow are regulated by raising and lowering the side walls or opening and closing the end wall vents. Temperatures inside an improperly vented tunnel can rapidly rise to over 100 degrees Fahrenheit within a few hours on a sunny spring day. In addition, the high humidity inside a poorly vented tunnel can lead to fungal and bacterial disease. As such, care must be exercised to closely monitor temperature and humidity levels throughout the day during the growing season. While proper ventilation is crucial to crop health during normal growing conditions, high tunnel growers must also consider minimizing wind stress during storm events. Standalone tunnels should be situated so that the prevailing winds move through the open sides or over the top of the tunnel rather than hitting the end walls. In other situations, such as multi-bay tunnels, it may be recommended to place tunnels parallel with prevailing winds. Regardless of positioning, tunnels are the least vulnerable when sidewalls and ends are closed. In some situations, potential wind damage can be offset in susceptible areas by creating or planting windbreaks, but ensure that the potential growth of windbreaks will not cause shade issues in future years. As mentioned previously, if you are unsure how wind will impact a selected tunnel, contact the tunnel manufacturer or local NRCS office for technical assistance. In areas where wind or drainage presents an ongoing issue, consult with a manufacturer's representative, regional installer, extension, or county NRCS staff person for advice on the best structure and placement for a specific situation, as well as solutions to wind and drainage issues. The same consultation should be considered when examining any unusual situation identified in the site selection process. Let's take a moment to review the major points in selecting a tunnel and site location. First, examine the types of tunnels and manufacturers available in your region. Next, from the ground up, assess the soil for drainage and fertility. Consider current management, including pest and weed issues. Assess physical accessibility for staff and machinery, water for irrigation, and access to light. Maximum airflow and light access will be achieved through tunnel placement during the construction phase for the high tunnel project. Now you have the basic tools to begin tunnel and site selection, but take the time to speak with local producers using high tunnel technology and ask questions about issues they may have encountered, localized concerns for drainage, soil fertility, and wind, or even recommendations for professional services. Also remember that tunnel manufacturers and installers want your tunnel to be a success and are more than willing to provide recommendations and insight. Finally, utilize your local extension, conservation district, and NRCS staff. Keep in mind, if receiving NRCS financial assistance for your tunnel, you should check with your county USDA-NRCS representatives prior to identifying the tunnel site, beginning installation, or making any changes to the manufacturer's design. Visit www.capitalrcd.org and select the High Tunnel Support Program option from the Programs menu for links to county representatives and online resources, including additional videos that are designed to help you maximize the growing and profit potential of your new high tunnel production system. This video was made possible by funding through the United States Department of Agriculture Natural Resources Conservation Service.